Hey guys, welcome back. In today's video, we're going to convert this small battery into a DC power station. For that, we're going to need a small charge controller that we can mount inside the battery. Our friends over at Bateria Power supplied this small charge controller for this video. I know a lot of you have subscribed because of my smaller 12-volt projects, in fact about 50%. So I'm grateful for that. And I don't want to be the channel that just goes in one direction and starts doing these big projects and leaves everyone else behind. I want to focus on projects, and I want to do everything from small to large. So with that, let's get started. Okay, so I have this battery here that I built in, looks like January of 2023. And what happened was the display that was connected to this port broke. I didn't want to buy a new one, I just wanted to install a power switch here so I can use the battery. So I was looking inside the battery and I'm like, wow, there's quite a bit of space in here. We got space over here. Maybe we can fit a charge controller there. We got space down here that we can maybe fit a USB PD module here and connect it up to the lid here. So effectively we can make a power station. We can connect the solar panel directly to the battery and charge it. And then we can use the battery via the PD module like a power station. That's where this charge controller comes in. Let's take a look. Okay, so this is the Bateria Power, or I had to look up how to pronounce this. If you put the tilde over the I, it would be Bateria, which means battery. How aptly named. And this is the Sunrock 10 MPPT solar charge controller. So this has a 10 amp output. They also make a 20 amp version as well. Now this particular unit is designed for automotive applications, which is why it comes with these SAE connectors. So we're going to have to cut those off for our purposes, but that's typically what this is used in, automotive/mobile application. So small and compact and somewhat waterproof is what you want. I think it's IP65, I'm not quite sure. We'll take a look at the website. It'll do gel, AGM, or LiPo4 batteries. And like I said, this is the 10 amp version, so it will only charge 12 volt batteries. A 20 amp version, however, can do 12 volt and 24 volt batteries. Along with the charge controller, you'll get two SAE connectors with pigtails, so you can just wire these into your vehicle or whatever your project is without cutting the ends here. And you'll also get a coupler. I thought this was a gender changer, but then I was looking at it, and it just appears to be a coupler. In case you want to extend your wire. I was surprised at the documentation they give you a quick start guide. So for those that don't know how a solar charge controller works, it's pretty simple. You just hook up the input to your solar panel, and the output goes to your battery. It comes with a Bluetooth app. Just scan the QR code. That's nice. And it comes with a nice user manual. No load loss, so your phantom draw, parasitic draw, is going to be about 20 milliamps, so that's not too bad. The max solar input is 30 volts. Okay, so you're going to want to use a 24 volt panel nominal. 10 amps max for the charging output. And your max solar input power is 150 watts for the 10 amp version. Operating temp minus 20C to 45C. Internal protection temperature, so it'll shut down if it exceeds negative 40 or 80 Celsius. So it's IP45, so it's just water resistant. Here's your LED indicators that tell you the charging state. The different battery types, AGM, gel, and LiPo4. And here's your air codes over here. Okay, other components we're going to need for this project are power switch, our flush mount XT60 connector, that'll go in the battery lid, and our USB QC 3.0 and USB-C 65 watt power module. Now this particular module actually shows the voltage as well, which is nice because the display that broke used to tell me the voltage and the state of charge, but now that we're just installing a power button, we're not going to have that information. So I made sure to get one that shows the voltage, so we can just look at the battery and instantly know what the voltage of the battery is. Okay, so first thing we want to do is remove this connector here, and then we're going to splice a switch in to this cable right here. Well, I pulled the cable off, but the whole thing is spinning. I can't get the nut to spin. Finally. Next time, don't put glue on it. Maybe just some Loctite next time. Alright. Finally. So this is all I have in the way of heat shrink, my tiniest heat shrink. These are really small, so I'm going to have to really be careful about my connections. Heat it up, or you want to strip it and just pull it off. It just takes that little piece that you melted, takes it right off. Okay, all the wires are tinned and trimmed. This is where I need helping hands. I know the heat shrink. Yeah, it worked out. Ooh, that's a good solder blob right there. Let's heat these up before we get too far. Two more to go. Looks good. All right. Okay, our power switch is complete. Let's see if it works. Just plug it in here. And turn it on. All right. I'm connected. I got discharge turned off so we don't accidentally create a short. But everything seems to be working. Okay, now we can mount the power switch in the original hole that the connector was in. Should fit nice and perfect. Put on the lock washer. Put on our ring nut. No glue this time. Okay, I think that does it. And a little bit of blue thread locker. Could never hurt. All right, very nice. Okay, now we can mount our USB PD module. I put a little pilot hole right here. Let's see if it fits. All right, perfect. All right, perfect. Oh yeah, we're good. It's just a tight fit, but we're good. Okay, so I traced the XT60 connector onto a piece of blue painter's tape, so we'll cut this out and see if we can stick it on to our lid as a pattern. So now we can trace around this as best as we can. I can't get the Sharpie. If I were to just try to trace around this, I can't get the Sharpie underneath there, so it would be totally inaccurate. Okay, so there's our basic pattern. Here are our implements of destruction. Not quite there, really close though. Good enough. I know it's not perfect, but what can you do? So the reason we need to be so accurate is the mounting holes are so close to the actual connector that we have to really make sure that there's still some meat left there. I'd like to see the RC hobbyists complain about these damn things. Or any drone pilots, I'm sure they've had to deal with these. Actually, it's pretty good. Works for me. Alright, so the big question is, can we plug in our solar charging cable, MC4 to XC60? And yes, we can. Alright, so these are the two wires that came with the USB PD module. I cut them, made them shorter, and I added large ring terminals on so it would fit on the terminals. This is the plus side over here. Put on our negative. I just want to test the PD module real quick to make sure I got the wires on the right poles. So we'll just quickly connect it to the battery. You should see, yeah, 13.2 volts. Okay, now we can put our lid away for now and start working on the battery. We got to remove the 4 mounting plate screws. Okay. First thing we're going to do is cut through these rails here. We're going to cut that off here and here. Basically, remove this whole middle section. We just want to retain these side rails. That's all we really need. So the way this battery is made, there's bolts on this side, but there's no bolts on this side, keeping this down. This is held in place by the plate. So once we disconnect this, we cut this, this will be floating. We'll have to glue this in place just to keep it there until we can put everything back together. Try not to damage the battery cells. This 3D printed stuff is sticky. Next, we need to cut out this portion of the fiberglass. I'm gonna have to remove the BMS. Where the hell did that come from? Man, that is some nasty stuff. Boy, this is turning into a project. Starting to look like a subframe to an RC car. This feels like such an RC car build. All right. By the way, if you want to know how I built this battery, because this is a DIY battery kit, I'll put a link in the description below. They should have put the screws on the top. It's kind of ridiculous. Oh, but you never have to take it apart again. Well, I don't know about that. Not unless you want to install a charge controller. Like, there's no reason. I actually told them about this. No reason whatsoever to have these screws on the bottom. Okay, BMS is back on. And we got our cutout. Let's do a little test fit here. Oh yeah, plenty of room, see? It goes right through there. You know, parts are completely different, you know, they had no idea that the other manufacturer was building it. But they just happen to work perfect. That's just one of those things. Okay, so I got this piece here, and I got it kind of held down with these screws for now. We're just going to tack it with some hot glue. There's a long bolt and a short bolt. I think the shorties, if I remember correctly, go on the back. And the longies go in the front. Look at all the airflow, right? That's a good improvement, right? Get some airflow under those cells. Time to install the charge controller. Okay, for the solar charge controller, we have the battery end over here and the solar panel end over here. So I decided I'm going to keep the SAE connector for the battery side. It's just less connections I have to make. So I've already extended the wires. I had to extend them a little bit and put ring terminals so it can connect to the lid on the battery. That side is done. On this side, on the solar side, we're going to cut this off and we're going to put some XT60 connectors to mate with the connector that we already installed on the lid. Yeah, so I could use the SAE connector as well on the solar side, but it was just getting too bulky inside the battery. I was running out of room, so XT60s take a lot less space. Make sure you cut the right wire. Okay, this will make up our XT60 connector. This is going to be really tight here. Okay, that completes the controller side of the connection. This is probably one of those cases where you want to use a butt connector instead, but I don't care. Gotta make sure that wire is nice and hot. It's a lot more solid connection right there. Okay, so looking at the lid, our main positives up here and our main negatives down there, battery terminals. We're going to have 3 connections going to each terminal. So we got the main battery positive here. We're going to have the PD module here. Well, that's nice. This crappy little fuse popped off. PD module there. And then the charge controller connection on top of that. We'll do the negative side of everything first. Okay, so now might be a good time to get our charge controller kind of positioned in here. Put that here. And this side has got to connect over to here. No! Too short. This is gonna be tricky. We can connect the battery side first. Just hope this thing can handle the heat, because this BMS can get quite hot under high amps. Okay, now this is gonna be the tricky part. Getting the positive connected up here. Oh, big battery cell. Might work. Alright, so we need this one, just like that. Charge controller on top. Our load or PD module in the middle. And our main on the bottom. I really don't want to make a longer wire, but Let's see if we can get it to work. Right. So everything's kind of there, if you can see it. And before I actually go to close the lid, I want to just see if the battery works. We're going to turn it on. See if it doesn't blow up on me. So I have discharge turned off. So I gotta go on the BMS app. Okay, we got discharge turned off. Go ahead and turn it on. And there it is. 13.2 volts. We've got a usable PD module. Come on, check it out. Charge controller. Let me Alright, so hopefully you can see the charge controller there. We've got 13.2 volts on the readout. And our state of charge looks pretty full. And it's set to gel, so we need to change that. So if you just single press it, it toggles through the different display options. There's your volts and your charging amps. That's your ambient temps, 33 Celsius or 91 Fahrenheit, so it gives you both Celsius and Fahrenheit at the same time. No, if there was an error, it would show here. So E00, no errors. So if you long press, it should change us into the settings for the battery. So now it's on gel. We'll switch it to AGM. One more time for the LFP. Long press to save, I'm assuming. Okay, it's saved. That's all there is to it. There's nothing more to do. Just change your battery type. It'd be nice if you really wanted, we could mount this so that the display is viewable from the top of the lid. But since it has a Bluetooth app, I'm not worried about that. We can always just use the Bluetooth app. Okay, the final build is complete. Let's check it out. And here it is. We got our port right there. The lid's on, nice and flush and sealed up. We got our USB PD module right there. Now for the crux of the video, the charge controller. Let's test it out. Here's the solar panel we're going to be using with the charge controller. This is Renogy. It's a 100 watt panel and it has a VOC or open circuit voltage of 24.3. So that is under the 30 volt max VOC of the charge controller. So this panel is perfectly suited with the charge controller. Okay, so here's our panel. It's going into the garage. And all the way over to the workbench. It's only about 100 degrees today in Vegas, but the humidity is 25%. That's a lot for Vegas, so it's hot today. Okay, so like any good test, we want to test it against some kind of control. So we're going to first test the panel output with our solar panel multimeter. Definitely got voltage there. Let's give it a couple tests. First pole was about 87 watts, about 88 watts. 88 again. 88. So we're getting about, exactly 88% of the total power output of 100 watts. Alright, so let's plug it in. We're going to be watching the Bluetooth app. I've got to connect to the device. Charge Pro. This is the Charge Pro app. So we can see our battery voltage is 13.2. And there's 0 amps coming in and there's 0 power coming in. Let's plug in our solar panel. See what happens. Okay, 0.21 amps coming in. Alright, 4.78 amps coming in, 63 watts. 74 watts. Now we're looking for that 88 watts or thereabouts. The panel's heating up, so the wattage might not be quite as much. Let's see what else this charge controller has to offer. Under historical data, we can see a nice graph. It gives a total charge amount, a total discharge amount. That's nice. Highest battery voltage, max charge power, a cumulative discharge amount, and a cumulative charge amount, and the lowest battery voltage. Regular, I guess not a line graph, but your bar graph here. What do you call these? Point graphs? I don't remember. All right, let's go to parameter settings. Oh, and it's by day, so you can just go to the previous day here. So here's where you would set all your battery voltage. If it's not already I'm going to unlock it, if it's not already predefined. So we're currently setting on lithium. You can do gel, SEL is sealed and flooded. And you got user defined, so you can come in here and change all these settings if you need to. Typical settings: equalize volt, boost, float, charge recovery, over discharge, boost charge time. Even has equalized charge interval. An advanced feature like that, that's typically not found on these smaller charge controllers, so that's nice. We're still charging with 75 watts. That's really all there is to it. So let's actually plug something into the USB PD port and see how that works. All right, so first I'm going to test out my cell phone. Now this is auto selecting voltage, so depending on the load, the device that you plug into it, it'll choose between 5 volts, 9 volts, 15 volts, and I think 20 volts for the high power devices. So this phone should run around either 5 or 9 volts, probably 9. There it goes, it selected 9 volts. Hopefully you can see that. We're pulling about 2 amps. That's a fast charge. That's about, say 2 amps times 13.4. That's 26 watts. I got a old school Apple iPad here. I think this is a 15 volt device. There it goes, it automatically selected 15 volts. You can see that. Yeah, 41% charged. How cool is that? We're using the power and we're charging over here with the solar panel at the same time. Plug in another device to the USB QC port. Now we're charging the flashlight and powering the iPad. And just like that, we converted this battery into a usable DC power station. Now I can use this to charge my DC appliances, USB devices, right? And I don't have to hook up an inverter. I can still hook up an inverter to the battery because it operates just like a battery. I still have my battery terminals. All you need, solar panel, charge controller, and the USB PD module. Now this battery is quite large. It's actually a 3 kilowatt hour battery, so I can charge a typical cell phone 127 times before I need to recharge the battery. So although this doesn't replace a small power station such as a Blue Eddy or Anchor, because they do include small AC inverters built in as well, so you got the total functionality of AC and DC, but this serves all your DC needs. You can have this panel mounted on a camper or on your RV, have the battery in your RV, and it's just great. You could probably use it the whole camping trip, at least for DC devices, without ever having to recharge it. If you're interested in the charge controller, there's a link in the description below. If you're interested in a video on how I built this DIY battery kit, link in the description below. Now obviously you can't just take this controller and stick it in any retail battery. There's no space for it, right? So what you would normally do is just connect it to the terminals and you're done. So it's a very simple to use charge controller. Alright, that's all I got for this video. Thanks for watching, and if you don't want to wait for my next video, check this one out right here.